Of every planet in our solar system, this is the one we actually plan on sending real human beings to within our lifetimes. But before anyone packs their bags, you should know exactly what's waiting for them, because Mars is far more dangerous than the calm red desert photos make it look. Today, we're putting a human on the Martian surface and walking through exactly what would happen. And the final danger on this list isn't something you'd feel right away. It's something that's been silently building up around you the entire time. Stick around for that one. The moment you stepped onto Mars, gravity would feel strange immediately, about 38% of Earth's, almost identical to Mercury. You'd feel noticeably lighter, capable of jumping nearly 3 times higher than you could on Earth with the same effort. The ground would crunch beneath your boots, a mix of fine reddish dust and rocky basalt, the iron-rich minerals giving the entire landscape its signature rust-colored hue. Dust devils, mini tornadoes formed by sunlight heating the ground unevenly, would occasionally spin past in the distance, kicking up small swirling columns of red dust. It would actually look almost peaceful. But that's deceptive, because the very next breath you tried to take would reveal exactly how unforgiving this place really is. Mars's atmosphere is roughly 95% carbon dioxide, and incredibly thin, about 1% as dense as Earth's atmosphere at sea level. Without a pressurized suit, your blood and other bodily fluids would actually begin to boil at normal body temperature within seconds. Not because it's hot, but because the atmospheric pressure is so low that liquids vaporize far more easily, a condition scientists call ebullition. You'd lose consciousness within about 15 seconds due to lack of oxygen, and without immediate pressurization, death would follow within roughly 1 to 2 minutes. This isn't a "you'll feel uncomfortable" scenario. Mars's thin atmosphere makes unprotected exposure lethal almost immediately, even though, unlike Venus, the air itself isn't toxic in concentration so much as simply not there. And the temperature swings happening around you would be just as extreme as the lack of air. Mars sits much farther from the sun than Earth, and with such a thin atmosphere trapping almost no heat, temperatures swing dramatically. Daytime highs near the equator can reach a relatively mild 70 degrees Fahrenheit in direct sunlight, but nighttime temperatures regularly plunge to around negative 100 degrees Fahrenheit, and near the poles, it can drop below negative 195 degrees Fahrenheit. That means within the same 24-hour period, you could experience a temperature swing of over 150 degrees. Simply because Mars's atmosphere is too thin to hold on to daytime heat once the sun goes down. On Earth, our thicker atmosphere acts like a blanket, smoothing out these swings. Mars has almost no blanket at all. So between the lack of breathable air and the extreme temperature swings, you'd need full protection just to survive an hour outside. But there's a slower danger that's been building this entire time, one that doesn't announce itself immediately. Mars lost most of its global magnetic field billions of years ago, and combined with its thin atmosphere, that means the planet has almost no real protection from cosmic radiation and solar particles constantly streaming in from space. On Earth, our thick atmosphere and strong magnetic field absorb the vast majority of this radiation before it ever reaches the ground. On Mars, radiation levels at the surface are dramatically higher, high enough that extended, unshielded exposure significantly increases long-term cancer risk, and a powerful solar flare could deliver a dangerous, potentially lethal dose within hours to anyone caught outside without heavy shielding. This is the cliffhanger danger we mentioned earlier. Radiation doesn't burn, doesn't freeze you, and doesn't suffocate you in the moment. It just silently accumulates in your body the longer you're exposed, which makes it one of the most genuinely difficult problems for any future human Mars mission to actually solve. Mars is also home to the largest dust storms in the solar system. Most years bring regional storms, but roughly once every few Martian years, about every 6 to 8 Earth years, a storm grows large enough to engulf the entire planet, sometimes lasting for weeks or even months. In 2018, a global dust storm became so thick and widespread that it completely blocked sunlight from reaching NASA's solar-powered Opportunity rover, which had been operating successfully for nearly 15 years. The rover lost power, went silent, and was never heard from again, ending one of the most successful robotic missions in space exploration history, brought down not by a mechanical failure, but by the sky itself going dark for too long. If you were caught outside during one of these planet-wide storms, visibility could drop to almost nothing, and any solar-dependent equipment you were relying on for power could fail right along with it. Here's a detail that surprises almost everyone. On Earth, our sky is blue during the day and our sunsets glow orange and red, because our atmosphere scatters blue light during the day and lets red light dominate near sunset. On Mars, it's almost completely reversed. Mars's sky typically appears a dusty butterscotch tan during the day, because fine dust particles suspended in the thin atmosphere scatter light differently than Earth's denser air. But around sunset, the sky near the sun often shifts to a cool blue glow, the opposite color pattern from what every sunset on Earth has trained your brain to expect. If you'd grown up on Earth your whole life, watching a Martian sunset would feel quietly, deeply unfamiliar. Beautiful, but undeniably alien. So here's Mars in full. Gravity light enough to make you bound across the surface, air too thin to breathe for even a minute, temperature swings of over 150 degrees in a single day, radiation silently accumulating with every hour you're exposed, dust storms big enough to end multi-year robotic missions, and sunsets that glow the opposite colors from anything you've ever seen. It's the planet most likely to host actual human visitors within our lifetime, and also a planet that makes absolutely no allowances for mistakes. Up next, we're leaving solid ground behind entirely and heading to a planet so massive there's no surface to even stand on. Stick around for that one,